Okay, guys. So the U value question, I have another video already up about that, but there is two types of questions B's that can be asked. One is the one we've already looked at, where they ask you to calculate how much it costs to heat the house for the year. The second question is this type of question, and I'll work my way down to it, but it just asks you to calculate the thickness of insulation that you're going to be required. Now, this is a 2010 question, which is for the first part A, is very straightforward. It's just asking you to calculate the U value of an uninsulated external solid concrete wall of a dwelling house. It was built in the 1950s and you're given the following information. So there's outside render, you have a solid concrete wall, and then you have internal plaster. So that's all my walls made up of. And then down here, instead of conductivities, I have all resistivities, and then of my resistance of my external and internal surface. So if we get going at that, I'm going to do out my table. I've already started on this one, but material, conductivity, resistivity, thickness, and resistance. And I'm going to start from the outside wall and work my way in. So my first thing is my external surface. Then I have my external render. I'm given my wall in the question, my internal plaster, and my internal surface. Now, I'm given my external surface. I'm straight away, I can go over, it's given my resistance already. So external surface is 0.048. External render, I'm given my resistivity for that is 2.17. The wall is 1.19, and the internal plaster is 6.25. I'll come back and fill in the thicknesses in a second, but my internal surface then is 0.122. Now don't forget, we're trying to get over this column filled out the whole way down. Thicknesses has to be in meters, so my 16 mil plaster external render I'm given in the question, in meters that's 0.016. My wall is 0.225 and my internal plaster is 0.013. Now, formulas I need. There are the usual formulas. R is equal to thickness over conductivity. Now in this question I don't have any conductivity, or my resistance is equal to my thickness multiplied by my resistivity. So basically I'm just going to multiply 2.17 multiplied by 0.016. Now I'm going to just fly along through this. So it's 0.035, 0.268 and 0.081. I'm just taking down straight from the answers or marking scheme, and I'm round them to 3 decimal places. Now, if I add all that up, I will get my RT, my total resistance. So adding all them up, I should get 0.554. And I know my formula from U value, for my U value is 1. U value is equal to 1 all over my RT. So 1 divided by 0.0554 should give me, well, I'll write it out, 1 divided by 0.554. That's going to give me 1.805. And then, just the handy way of doing this, if my resistance is meters squared degrees Celsius per watt, the opposite is going to be, so if you flip that around the other way around, to get my U value, it is watts per meters squared degrees Celsius or Kelvin, whichever way the question asks for. Now, part B of this question, excuse me. Part B is they are going to put on foam insulation is going to be fitted to the external surface of the solid concrete wall. Given the conductivity of the phenelectric foam, 0.025 watts per meter squared degree Celsius, calculate the thickness of the foam required to achieve a U value of 0.27. So I know from part A of this question, part A, that I have a U value of 1.805. And how am I'm going to put insulation onto the wall, and I'm going to try and bring that U value from 1.805 the whole way up to 0.27. So we're kind of going to work in reverse through this. So for part B, I am going to work in reverse. So our formula, U is equal to 1 all over RT. We can rearrange that around and give me the total resistance is equal to 1 all over my U value. Now, I know in this case, 1 divided by my U value for part 2 of this question is 0.27. 0.27, yeah. So 1 divided by 0.27 should give me, my total resistance should be 3.703 meters squared degrees Celsius per watt. The opposite way around is this. Now, I know that my new U value has a total resistance of 3.7. My old one has this. So I'm going to just take these two numbers away, and that's going to give me the resistance for the new insulation. So the resistance of the insulation is going to be 3.703, take away 0.554. So that should give me 3.15 meters squared degrees Celsius per watt. So the insulation has to give me that resistance. In the question, I am told, so if I go back to the question for a second, I am told a conductivity of 0.025. So I'm given a conductivity and I'm going to try and calculate the thickness. So I'm going to write this formula again. R is equal to T over K. Now that is the exact same if you bring your K across. So T is equal to R multiplied by K. The thickness I don't know, but I do have my resistance, which is 3.15 multiplied by 0.025, and that should give me 0.079 meters. Multiplied by 100 to get that, or 1,000, sorry, to get that to meters, will be 79 millimeters of insulation required to bring the U value up from 1.8 to 0.073. Sorry, you didn't see any of that. Okay, so that's the first two parts of that question done. Sorry about that last bit.